All right, guys, here we go. We're going to be talking about solving equations with rational exponents. What is a rational number? I know that these things get really scary because you guys might have flashbacks to seventh grade where it's like, what's an integer, whole number, natural number, blah, blah, blah. A rational number is any number that can be written as an exponent or as a fraction, So anything that can be written as a fraction. That's anything that can be written as a fraction. So think of a couple numbers, put them in a fraction, you're done. Even 5 is, because you can write 5 as a fraction, but also like 21 over 1,732. That's a fraction, or that's a rational number. These are all rational numbers. All right. A rational exponent is an exponent that is a fraction, and it's tied to roots. So these are related to roots. And when I say roots, you guys, I mean like a square root, a cube root, stuff like that, related to roots. And I'm going to show you how you put a root into a fraction, a rational exponent. And I'm going to start with this guy right here. So that's a third root, which means it's equal to x to the power of 1 over 3. Okay, so when you have a fraction exponent and there's the number on the bottom is a root. So for example, the fourth root of x would be x to the 1/4. The fifth root of x is equal to 1, or x to the 1/5. Now let's go back to this guy here. This is your classic square root. Now see how there are all these numbers here. There's the 3, the 4, the 5. There is a number right there hiding. But what do you think that number is that's hiding? That we don't typically write? It's a 2. So this is equal to x to the 1 over 2. So these next ones should be pretty easy if you follow the same pattern. This is x to the 1 over 20th. Now remember, we're not multiplying by these fractions. It's a power, to the power of. So this here is x to the power of 1 over 73. X to the power of 1 over 100. X to the power of 1 over 253. Okay, it's the 253rd root of x. All right, so that's your basic. That's what you got to know. A root is can be converted into a rational exponent. And it has to go on the denominator. Now, how do you rewrite an expression that has a root and an exponent? This is what you would do. This guy, the first one here, has a third root and an exponent of 5. So remember, we're going to say x to the 5th, and then a root goes on the bottom. The root always goes on the bottom. So this is going to be x. The exponent is 2 squared, and the root is 7, like that. This guy here is x to the 9th, and with a root of 8. I want you guys to pause real fast and do the next 3 as best as you can. Remember, this guy here, there's something hiding. So go ahead and pause and try these 3. All right, I've had a sip of my coffee. X to the power of 10 over 4, your root is 4. X to the power of 3, what's your root here? It's a square root. There's a hidden 2. x to the power of 6 with a root of 11. The reason why mathematicians convert these is because it's easier to solve equations when there isn't this root house, which you guys are going to get to in a little bit. All right, now sometimes they're written like this. This is the same idea. It has an exponent and a root, and we convert it the same way. So x, the exponent is 8, and the root is 3. X, the exponent is 3, and the root is a 2. X to the power of 5 with a root of 4. Now I want you guys to try these last 3. So go ahead, quick pause, and try these last 3 here. All right, let's check your work. This one is x to the 4/5 power, x to the power of 7/10, and x to the power of 9/2. Because remember, there's a little baby 2 right there. All right, so that is that. What is next? Now we're going to go backwards, you guys. So this has a rational expression, and we're going to write it as a root. So remember, the number on the bottom of the fraction is a root, and the top is your power. So we have a power of 1, and then a root of 5. So that's how we're going to write this. We have a power of 1 and a root of 2. Now, I want to talk about this real fast. Mathematicians are not going to write things like this. They're just going to write x with a square root. Those two things are equal. And this one here, they're only going to write the 5th root of x. They're not going to put an exponent of 1. But if the exponent is a number other than 1, then they are going to put that. All right. So this next one here, x power is 7, and the root is 4. I want you guys to try, we'll do this last one here. The power is 2, and the root is 9. So you know what we're going to do, actually? We're going to go back here, and I'm going to add to this definition. And I'm going to write out what everything means in the fraction. It's power over root. All right, I want you guys to try these last 4, and then, so hit pause, do these last 4, and then come back and check your work. Okay, the power is 6, and the root is 5. The power is 5, but the root is 6. The power is 2, and the root is 11. And the power is 11, and the root is 2. This one we can rewrite to look like this, because we don't usually write down second root. We just write down square root. All right, so that's the big idea for this learning target. The next thing that we're going to do, you guys are going to have to remember about reciprocals. A reciprocal is when you flip a fraction. Super basic. So the reciprocal of 4/5 is 5/4. You just flip it. Flip it. But that there, you guys, turns into a 2. Flip it. Flip it. This is a reciprocal. Reciprocal. Ooh. What do you guys think of these? How do you flip a 3? Well, if I look at this example, a 9 can turn into that's a fraction, right? And if I flip that fraction, it looks like that. So the reciprocal of 3 is 1/3. This guy's easy. Flip it. Ooh, what's the reciprocal of 7? 1/7. And what's the reciprocal of 2? 1/2. So you guys are going to want to remember that, especially for the next part of this standard. Alrighty, good luck on your quiz.